We begin our next unit with polynomials. Polynomial functions in polynomial form are a sum of terms consisting of x's raised to positive whole number powers. The degree of the polynomial is the highest power of x in the equation. Polynomials can also be written in factored form. In that form, the degree of the polynomial is the number of factors. Determine the degree of each of the following polynomial. The degree of the polynomial is the highest power of x in the equation. So this means 4 is the degree of this polynomial. In the next example, the degree of the polynomial is the highest power of x in the equation. The highest power of x in this example is a 1. So the degree is a 1. In the next example, we have a factored polynomial. In that form, the degree of the polynomial is the number of factors. I have 1 factor here and 2 factors here. So the degree is 3. To determine the roots of a polynomial, put the polynomial in factored form and set each factor equal to 0. The degree of the polynomial should be the same as the number of roots. So in this first example, I have 2 factors. Set each factor equal to 0 and solve for x. So x is equal to 2, or x is equal to negative 3. In the next example, I have 3 factors. Set each factor equal to 0. So x equals 0, x minus 1 equals 0, and x plus 4 equals 0. So x equals 0, x equals 1, and x equals negative 4. Polynomials share some characteristics with the parent function with the same degree. I've sketched the following parent functions: y equals x to the first, y equals x squared, y equals x cubed, and y equals x to the fourth. Notice they all have a root of 0, but the powers are different. The exponents attached to the root create the different appearances as the graph touches the axis. All roots of the same type behave the same way. If a root has an understood exponent of 1, it is called a single root, and it will pass through the axis at the point like y equals x did at 0. So this has a degree of 1, so it is a single root. If the exponent is 2, it is called a double root and will bounce off the axis at the point like y equals x squared did at 0. So for the parent function y equals x squared, we have a double root. So if you're looking at the graph decreases towards 0. Once it hits 0, it bounces off and heads the other direction. If the exponent is 3, it is called a triple root. And it will flatten out as it passes through the x-axis like y equals x cubed did at 0. The line approaches 0, bounces off in 0, and would have headed back down the other direction. That would have been a double root. But instead, it bounced twice. It bounced again as a triple root. So it bounced and went the other way. Determine the degree and roots, including the type of each polynomial. I have a 2 and a 3, so the degree is 5. Let's set each factor equal to 0 to determine what the roots are. So x squared equals 0, and x minus 3 equals 0. Well, when I solve for x squared and take the square root of both sides, x is equal to 0. When we add 3 to both sides, we get x is equal to 3. So I have a double root at x equals 0 and a triple root at x equals 3. It's a double root because of the squared. It's a triple root because of the 3. Let's look at the next example. X plus 1 and x minus 3 squared have an understood degree of 1 here. So this one would be a single root. This factor has a degree of 2. So this is a double root. The degree is the number of factors. So I have 2 factors here and 1 factor here. So the degree is 3. Set each factor equal to 0 and solve. So x plus 1 equals 0 and x minus 3 equals 0. So x is equal to negative 1 and x is equal to 3. X equals negative 1 is a single root because of the 1, and x equals 3 is a double root because of the 2. The next example, I do need to factor, so we're going to follow our rules of factoring. Pull out the GCF first, then look to see if there are 2 terms, 3 terms, or 4 terms. If there are 2 terms, we look to see if it's a difference of squares, if it's a difference of cubes, or sum of cubes. If there's 3 terms, we can do the snowflake method, or grouping, or the box, whatever you want to use. And if there's 4 terms, we just use the grouping. So the first thing I want to do is pull out the GCF. Then at the very end, we check to see if we could still factor. So anytime we have a degree bigger than 1, we need to check to see if it can factor. Notice I could pull out a negative x in this term, and we're left with x squared minus 25. So this has a degree of 1. I'm done with this factor. Look at the next factor, and it has a degree of 2. So I'm going to follow the little flow chart here. This has 2 terms. Is it a difference of squares? We know it's not a difference of cubes or sum of cubes because this is a square, not a cube. This is a difference of squares. I could rewrite this as x plus 5 times x minus 5. Remember, negative x was already pulled out. Now we set each factor equal to 0. X equal to 0, x plus 5 equal to 0, and x minus 5 equal to 0. And then we solve for x. Well, the first one's already solved for x. The second one is going to be x equals negative 5, and the third one's going to be x equals 5. And these are all single roots. The end behavior of a polynomial describes what happens to the far left and far right of the graph. If the leading coefficient is positive, the graph will behave like the parent function of the same degree. If the leading coefficient is negative, the entire graph will be reflected, and the starting and stopping places will be opposite of the parent function. There are 4 different options for graphs. If we have an even degree graph, it's going to start above and end above the x-axis. So its motion is up to up. For an odd degree graph, it's going to start below and end above. So its motion is down to up. If I have a negative leading coefficient, it's a reflection. So instead of opening up, it's going to be down. So it starts below and ends below, down to down. For the next one, because it's reflecting, instead of starting down to up, it's going to go up to down. So it starts up or starts above the axis and ends below. For each polynomial below, determine the degree, end behavior, and type of roots. If the polynomial is not factored, factor it first. So in this first example right here, the degree is a 3. That's the highest degree in the polynomial, so the degree is 3. The leading coefficient is positive. So that means since the leading coefficient is positive and it's a degree of 3, then it is moving down to up. Now we need to find the roots, but to do that I need to factor. In this first problem I have x cubed minus 4x squared plus 4x. The greatest common factor is an x, so we pull this out. We're left with x squared minus 4x plus 4. Now I could still factor x to the first power is done, but notice I still have a 2 here. So following the flow chart, I go back down, and this is not 2 terms, it's 3 terms. So can I use the snowflake method to factor? 1 times 4 is 4. The middle term is a negative 4. So each term factor is going to be x minus 2 and x minus 2. So what are the roots? Well, remember we have to set each of these roots equal to 0. So x equals 0, x minus 2 equals 0, and x minus 2 equals 0. That's one of the roots. It's a single root. The other root is x equals 2. But since I have that twice, it is a double root. Next example. Notice that both of these terms have a negative x cubed in common, so I'm going to pull that out. Negative x cubed. What's left over is x plus 3. Set each factor equal to 0, well, x cubed equals to 0, and solve for x. X is equal to 0, because I have to take the cube root of both sides. And x plus 3 equals 0, so x equals negative 3. The degree of the polynomial is a 4 because that's the highest degree. The leading coefficient is negative. So since this is a degree of 4 and the leading coefficient is negative, it's going to go down to down. It's going to have this look to it. Because this is x cubed, it is a triple root. X equals negative 3 is the other root, and that is a single root. In the next example, we have x to the 4th minus x cubed minus 20x squared. Let's pull out an x squared. When we factor, we are left with x squared minus x minus 20. Now x squared, I can't factor this anymore, but I can factor x squared minus x minus 20, and that's x minus 5 and x plus 4. Set each of these factors equal to 0 and solve. So x squared equals 0, so x equals 0. That's one of the roots, and it's a double root because of the squared. X minus 5 equals to 0, so x equals 5, and x equals 5 is a single root. This is the type of root, it's a single root. And x plus 4 equals 0, so x equals negative 4. Negative 4 is also a single root. The highest degree of this polynomial is a 4, and the leading coefficient is positive. So since it's an even root and it's positive, this will be up to up. For the next problem, this is already factored. What is the degree? Well, there's an understood 1 here. There's an understood 1 here. So I have 4 plus 1 is 5 plus 1 is 6. So the degree is 6. This is positive, so we know it's opening up. Looking at our little chart, it's an even degree, it's positive, so it is moving up to up. What are the roots? Well, set each factor equal to 0. X equals to 0, so 0 is a root and it's single. X equals 2, that's also a single root. And when we set x plus 4 equal to 0 and we get x equals negative 4 is a quadruple root.